Here's part 5 of getting started with SPSS syntax. In this section, we're going to be filtering data with syntax. Now, for people who have done this within SPSS using a dialog, chances are you've used the select cases dialog. And this allows us to create a condition or to type in a condition like if condition is satisfied, select cases if age is greater than 30. So in other words, only those cases where age is greater than 30 will be selected. It effectively filters out anybody who is 30 years old or younger. Now the thing is that that's a relatively simple statement there. So people are often surprised and somewhat confused when they hit the paste button in this dialog because it tends to generate surprisingly complex syntax. This is the pasted syntax for this particular statement here. And it's actually comprised of 8 different procedures: dataset activate, use all, compute, variable labels, value labels, formats, filter, and execute. So let's just try to unpick it and see the logic of what's actually happening here and see if there are other ways for us to achieve the same results using our own typed syntax. The first thing is that the reason the paste syntax is so verbose is that the dialog's actually creating what's called a filter variable. And it calls this filter variable filter_$. It just calls it that because it's a system variable. It doesn't have to call it that. You can actually edit this syntax and give it a different name. But that variable effectively marks which cases were included in the statement and which cases were not included in that statement. So which ones were included for the selection, which ones were dropped for it. And if you're included, that means you're aged over 30. And if you're not included, that means you're either missing or you're aged 30 or younger. So if we look at the statements themselves, we can see that first of all, we've got a dataset activate statement here. We talked about this already. And that's actually $dataset. So we know that we're in the mode where SPSS can only open one dataset at a time. Then it has this use all. That just basically means switch off all filters, use all the data. So it's basically resetting it. And then it runs a compute, and it computes a new variable called filter_$. It's a filter variable. It's using a Boolean statement. That means it's just a binary yes/no statement. And it's basically age greater than 30. So this is a trick you can use in SPSS and computing. It just basically says if you are aged greater than 30, you get a value of 1. And if you're not aged greater than 30, you get a value of 0. So it immediately creates this variable that marks those who are older than 30 and those who aren't. And then it attaches a variable label. We saw this in the previous section. It just gives it a label, tells you what that filter does. It's age greater than 30, that's what it's filtering on. It attaches some value labels in case you forget which one's selected and which one isn't. 0 means it's not selected, 1 means it was selected, meaning they were aged over 30. And then it runs a little formats command. Formats here is just a way of cleaning up the formatting of the variable. In this case, it's getting rid of decimal places. It's saying that it should have a numeric width of 1 with 0 decimal places. And finally, it runs this very simple little statement that says filter by. And this is the actual filtering statement saying filter by this new filter variable that's been created, which is called filter_$, and it executes that. So we're going to turn our attention to this filter command here, and how that works and whether or not we can use it without having to paste all the syntax in from the select cases dialog. So filtering data with the filter command, generally speaking, if you're typing your own filter syntax, is usually less complex than the pasted syntax that you got from select cases. But the filter command, we can see the filter command is quite limited. It says we can filter any cases that are equal to 0 or have missing values. That's basically all it does. So if we have a variable like minority, and minority has 2 values, 0 meaning no, I'm not in a minority group, and 1 meaning yes, I am, and you run the following syntax, filter by minority, the outcome will be that it selects all cases that are in the yes group, since it basically filters out any cases equal to 0 or have missing values. So all the 0 group would disappear. Let's just have a quick look at what that would look like. So here in the SPSS syntax window, I'm just going to read my data file. There's employee.sav right in. Let's do a frequency table in the variable jobcat. So we can see here that the variable jobcat has a value marked as 0. There's one case in here which is 0. And it's actually a missing value, but if for whatever reason you wanted to get rid of that case and you use the filter command, as we know the filter command filters out anything equal to 0, anything which is missing, so it meets both conditions. Come back here, I can say filter by jobcat. The filter by jobcat is now switched on, and if I now run frequency jobcat, we get a second frequency table. You can see that 0 now has disappeared. And then to switch it off, I'd use filter off. Okay, so that's my command. Switches it off, filters off, and now I'd run frequency jobcat again, and we're back to the original frequency table. So that case is now included again. So that's one example of using the filter by command. Now, the obvious limitation of the previous example is the filter by command simply filters out anything which is equal to 0 or missing. And if you actually wanted to filter out cases which weren't equal to 0, weren't missing, that would require you then to, if you wanted to use the filter by command, you'd have to identify those cases. And as we saw in the select cases example, when we paste the syntax, that's what it's doing in the background. But just to make it clear, we can do our own version of that. We can use commands like compute or recode to recreate what the select cases dialog does. We simply create a new field that marks any cases you don't want to include in your analysis with a 0 or a missing value, and then we use the filter command to select everyone else. So for example, if we look at this syntax here, we've got some comments. This compute command simply creates a variable for 1 or a 0. Managers over 40 are given the value of 1. Everyone else is given the value of 0. So if I run that compute statement, compute a new variable called older managers is equal to jobcat is equal to 3 and age greater than 40. Again, it's a little trick. If I run that procedure, it creates this field which marks managers because they're in jobcat 3 and age over 40 with a 1. Everybody else gets a 0. And then all I have to do is say filter by older managers. Let's have a look at that. If I just skip out to SPSS. So here we have this variable here. So compute older managers equal to jobcat 3 and age greater than 40. Let me just run that first of all without the execute so you can see what I mean by the effect of the execute to run that. And we'll go and have a look at the data. So here is the variable that's been created, but as I say, you usually have an execute statement to actually populate the values in the column itself. The values are held in memory at this stage. So execute just flushes the data. In fact, any new procedure would flush the data, would do the same thing. But if I just run execute here, it just sort of makes a pass of the data. And now it's marked with 0s and 1s. So there's somebody here with a 1. Why are they a 1? Well, they're a manager. What's their age? They're 43. So they meet the condition. Okay. So now we come back to selecting and filtering cases again. And we simply say, okay, we've got this new field, older managers. Filter by older managers means select only those with cases with a value of 1, meaning they fall into the older managers group. So you hit run at that selection. Let's go back here. Okay, so you can see it's actually physically removed cases from the data view here. These are all of these cases here are people aged over 40 and they're all managers. But we could run a little procedure to check that and to say, just do a means table showing me the minimum maximum age broken down by job category. And if I run that, it says, okay, there's only one job category here, this manager, and the minimum age was 41 and the maximum was 55. So we know that everybody is at least aged 40 or over 40, sorry. So if we want to come back here and switch that off, again, we simply run filter off. Run that again, come back to the data. There's all of the data. We can check it again now with our little means table again. And we'll see clerical, custodial managers and the full range of age groups within those different job categories. Okay, so we've looked at the filter command, but it turns out that's not the only way in which you can filter data with SPSS. There is actually another procedure called selective. And selective actually has an advantage over the filter command in that you can use it to specify a conditional statement. You could say select if age is greater than 30 and gender equals F and region equals 17. So it's not going to just filter out any cases equal to 0 or that have missing values attached to them. You can actually define quite a complex conditional statement, in which case people might say, well, why would you use the filter command? Well, one of the downsides to the select if command is that it permanently selects cases for analysis based on a logical expression. In other words, it will delete the cases that don't get evaluated by that expression, that don't fall into that particular category. Now, like the compute command, the select if command only really takes effect when another procedure like frequencies is run after the command is executed. And that's why execute is added as a separate command. So select if age greater than 30 will obviously select people who are age greater than 30, over 31 or over. It will permanently delete all of those cases that don't meet that criteria, but it won't take effect until another procedure is run. That's why we add an execute statement at the end of it. Now, it turns out there is hope. There's another way around this so that it doesn't permanently delete your data, and that is to use a procedure known as temporary. Okay, so a simple way to get around the selective permanently removing data is to use the temporary command beforehand. This is useful if you want to filter out unwanted cases for the next immediate procedure. So if we type temporary full stop, select if age greater than 30, and then run two frequency tables on the variable jobcat, the first frequency table will be only people aged greater than 30, so the temporary selection takes effect. But the second one, the temporary, the selection is now switched off, and it will show all of the people in the data set, irrespective of their age. Let's have a look at that. So here we are back in the SPSS syntax window looking at this last example. And we have the command temporary here. Temporary, just a single word with full stop after it, meaning that the select if statement, which would normally be permanent, is only going to have temporary effect on the subsequent frequency table, but it won't have any effect on the next and final frequency table after that. So we've got frequency jobcat run twice. First one, temporary selection takes effect. Second one, temporary selection switched off. GT stands for greater than, so it's just exactly the same as the greater than symbol. If you're wondering why this doesn't have an execute statement after it, it's because frequencies does the same thing as an execute statement. It basically flushes the data. So let's run the procedure. We'll see two frequency tables, one that only relates to people who are aged over 30, the second one that relates to all of the employees in the data set. Let's run that. There's the first frequency table, 236 employees in that. They're all aged over 30. The second frequency table is run again. The temporary selection is switched off, and we have 475 cases in this second example.